Alright, so today we're talking about surface area and volume of pyramids and cones. So really it's just following some more formulas. There is some vocabulary that you need to be familiar with and some situations that happen in the figures that you need to be familiar with. Now, a regular pyramid is one in which the base is a regular polygon and the segment from the vertex to the center of the base is perpendicular to it. So here is a pyramid, okay? It's got a triangular base and it's an equilateral triangle, so that's what makes it a regular pyramid. The segment that goes from the vertex perpendicular to the base is your height. It also goes to the center of the base in a regular pyramid. Now, a new term that we want to talk about is the slant height. Okay, and the slant height is the height of the lateral face. Okay, it's the height of the lateral face. If you look here at this thing, got twisted. Put this piece of paper in here, and you can kind of see that here's the lateral face, and then this red little string here is the height. That's called the slant height. Okay. This gold thing that's on the inside is actually the altitude or the height of the pyramid. All right. That's this thing. This is the altitude or the height of the pyramid. Okay. You get some little triangles that occur inside your pyramid. Okay. If I take where my altitude drops and connect it to where my slant height ends, I actually get a little right triangle. So you can see it right here. Okay, you see how the altitude and the slant height and then that little possum right there, they make a right triangle. You can get another right triangle with the lateral edge, the height, and then the radius, what goes from the center to the vertex. You see you get another little right triangle right there. Okay, and so you might have to utilize those. Here's another one. That would be a little right triangle as well. Okay. All right. So the formula for the lateral area of a regular pyramid is 1/2 the perimeter times the slant height. Okay, 1/2 the perimeter times the slant height. Or you can think of it as the perimeter times the slant height divided by 2. It's the same thing. And then your total surface area takes that lateral area and adds one base to it, okay? Because your pyramid just has one base. You know, and just like I said before, it is important that you write those formulas down because, you know, you're going to be going between pyramids and prisms. You know, the pyramid has one base, the prism has 2. So you look at the shape, you write the formula down, and then you work the problem, okay? All right, so let's work this one. This one's pretty easy. We want the lateral, which is the perimeter times the slant height divided by 2. Now, it's a regular base because it's a regular pyramid, so the base is a square, so what would my perimeter be? 16. 4 times 4 is 16. So I take 16, it gives me the slant height, which is 7, divided by 2. And so that's 8 times 7, which is 56 centimeters squared. That's the lateral. Then the total is the lateral plus the area of one base. My lateral, we said, was 56. And what's the area of my base going to be? It's a square, so it's base times height, which is 4 times 4, which is 16. So that makes my total 72 centimeters squared. All right. Let's do another one. This time it asks us to find the surface area of the regular pyramid. Okay? So lateral again is beta, perimeter times the slant height, divided by 2. Now, it's a regular hexagonal base. So what was the perimeter? How would we find the perimeter? 4 times 6, which is 24. So it's going to be 24 times the slant height, which is 12, divided by 2. So what's the lateral surface area going to be? 144 inches squared. Then the total is the the lateral plus the area of the base. Lateral plus the area of the base. So we've got 144 plus, now I gotta come over here and find the area of the base. And the area of the base is a regular hexagon. So I have to go and use everybody's favorite formula, perimeter times apothem divided by 2, right? We already know what the perimeter is, right? We found it to be 24. But we need to figure out what the apothem is. So remember, we have a hexagonal base, okay? We have to, and we know that the side length is 4. We have to find the measure of the central angle, which is 360 divided by 6, which is 60. Okay, so this angle here is 60, and then I drop that altitude, which is also the apothem, and what does it do to that angle? Okay, cuts it in half, so this becomes 30, and then this little piece becomes 2. So I've got this right triangle, where this is 30, this is 2, and I need this little apothem. It's going to be 2 radical 3. Divided by 2. Now, my 2's are going to cancel, and so I end up with 24 radical 3 for the area of my base. So I come over and add that to the lateral. So it's 144 plus 24 radical 3, and that's 185.6 inches squared. Okay, now we're going to talk about the cone. Okay, now within the cone, we talked about what an axis was. At least I think we did. Remember, an axis goes from the vertex to the center of the circle. In a right cone, the axis is also the altitude. Okay, in an oblique cone, it's not. Okay, the altitude doesn't necessarily go to the center, but in the right cone, it goes from the vertex to the center. And we're going to be primarily dealing with the right cone. Now, the cone has a slant height also, and it goes from the vertex to the base edge. Okay, it goes from the vertex to the base edge. It's the height of that lateral side there. And within the cone, you can get a little right triangle also. If you connect the radius from the altitude to the slant height, you get a little right triangle. Okay, looks like this. Okay, so there's the gold part, there's my altitude, and then this is my slant height, and there's my radius. Okay? Alright. The formula is basically half the circumference times the slant height. It's a lot like the prism, or the pyramid, except for it's pi times the radius times the slant height. Okay? This is more of an expanded version. The total surface area is, again, the lateral plus the area of the base. The area of the base is always a circle. So the expanded version of this would be pi times radius times the slant height plus pi r squared. So let's do one of these. We want to find the surface area of the right cone. What am I missing here? What do I need? I need the slant height. Because my radius is 5. What kind of triangle are we dealing with right here? It's a 30, 60, 90. Okay, and my radius is 5, which is also my short, right? My slant height is my hypotenuse. What's it going to be? 10. Okay, so my lateral is pi times the radius times the slant height. My radius is 5, and my slant height is 10. So my lateral is 50 pi, which is approximately 157.1 feet squared. Alright, any questions on that? Alright, now let's look at this cone here. We have to find what? Oh, we did. I was ready to go on to the next one. Alright, so that would be the lateral plus the area of the base. What is the area of the base? 25 pi, right? The radius is 5, so 5 squared pi. So So we've got 50 pi plus 25 pi, which is 75 pi. That's the exact answer. So 75 pi would be 235.6. That's feet squared. Now we're done, right? Okay, so here's another one. I need to find the lateral, which is pi times the radius times the slant height. I have the radius, it's 12, but I don't have the slant height. What am I going to do this time to figure it out? The Pythagorean theorem. Is this a triple? Yes. It's a 3, 4, 5. What are we multiplying by? 4. So 3 times 4, 4 times 4, 5 times 4 is going to be 20 for our slant height. Okay, so we got pi times the radius, which is 12, times the slant height, which is 20. So that's a lateral surface area of 240 pi, which is approximately 350 feet squared. All right. Now my total is the lateral plus the area of the base. So my lateral is 240 pi. And then what's the area of my base going to be? 144 pi. Okay. So plus 144 pi. That's going to be what? 384 pi. Which is 1,206.4 feet squared. Any questions there? No? Okay. Now we want to talk about volume. And I think maybe the hardest, I've said this a bunch of times, but I think maybe one of the hardest things is going back and forth between the formulas. It's really going to help you if you write them down for every shape that when you're working that problem, write it down. The volume of a pyramid is 1/3 the area of the base times the height, or the area of the base times the height divided by 3, same thing, okay? And the area of the base, you do whatever shape the base is. And really, your cone is the same formula, okay? This first example here says Travis is making a plaster model of the food guide pyramid for a class presentation. The model is a square pyramid with a base edge of 12 inches and a height of 15 inches. Find the volume of the plaster needed to make the model. Now notice, volume uses height, surface area uses slant height, okay? Make sure you use the right one, the right thing. Okay, so my lateral is area of the base times the height divided by 3. All right, my base is a square, correct? So what's the area of my base going to be? 20, what? 144? 12 times 12, which is 144. So 144, it gives me the height. What's the height? 15 divided by 3. So it's basically 144 times 5, which is 720 for the lateral. And that's inches cubed because we're in volume. I did, because I divided 3 into 15, which goes 5 times. Doing some mental math, right? You guys do mental math all the time. You leave all kinds of steps out on me. Yes? Wrong letter. I did the formula right, that's what you know, right? Volume, thank you. This one's a me too. Okay, so volume, we're done with that, right? Okay, cone, like I said, basically the same formula. Area of the base times the height divided by 3. You can also do pi r squared times the height divided by 3. Same thing. That's for the cone. Okay, so this problem, I have everything, don't I? It gave me all the information that I needed. Pi, my radius is 5 squared, times my height, which is 12, divided by 3. 5 squared is 25. 3 goes into 12 4 times, so that's basically 100 pi. And that's 314.2, correct? Centimeters cubed, because it's volume. Alright, any questions on that? Now let's do a couple little crazy ones. Okay, still a cone, still going to be pi r squared times the height divided by 3, right? I have the height, that's 10. I don't have the radius though. I have this right triangle, and I've got this angle down here, which is 48. What's this one up here going to be? 42? Okay, 42. All right, and I need to find my little radius right here. What can I use? SOHCAHTOA, which one? The tangent, right? And I could use either angle. Which one would you rather use? I'd probably use the top one, right? So we're going to do the tangent of 42 equals opposite over adjacent. So we multiply both sides by 10, and my radius is 10 tangent of 42. 10 tangent of 42. So I come up here and I've got pi times 10 tangent of 42 squared times my height, which is 10, divided by 3. Now, you can do this, you can plug it into your calculator in a couple of ways. If you want to do it all in one step, you would need to open a parenthesis to begin with and do 10 tangent, open and close the parenthesis around the 42, and then close that whole thing before you square it. Then you can multiply by 10 pi divided by 3. The other thing you can do is 10 tangent of 42 and then square it. Hit enter and then square it, and then multiply by 10 pi and then divide by 3. However you want to do it. Well, let's see what the answer will be here. 10 tangent. I get 849. Still got 849. Millimeters. Any questions on what I did there? Okay. Now, an oblique cone. In an oblique cone, for volume, you do the same thing. You're still going to go pi r squared times the height divided by 3. Okay? So I come over here, though, and I cannot have my height, nor do I have my radius. Well, what do I have? I have a 45, 45, 90, right? And a 45, 45, 90, the hypotenuse is radical 2 times the leg. So if my hypotenuse is 16, what do I have to do? Divide by radical 2, what do I end up with? 8 radical 2, right? Multiply the top and the bottom by radical 2. Remember, it's always half the hypotenuse times radical 2. So my height here is 8 radical 2. My diameter is 8 radical 2. What does that make my radius? 4 radical 2. Okay, so I'm going to come over here and do pi times 4 radical 2 squared times 8 radical 2 divided by 3. And you can do this in a couple of ways. You might want to simplify the 4 radical 2. What is 4 radical 2 squared? A lot of us miss this on the test. 16 times 2, right? 4 times is like 4 radical 2 times 4 radical 2, which is 16 times 2, which is 32. So we end up here with 32 pi times 8 radical 2 over 32 pi times 8 radical 2 divided by 3. And you could go ahead and, I think it would be safe to plug it in there. You just don't want to plug everything in at once and just make a mistake in how you plug it in. 32 pi times 8 radical 2 Make sure you close the parenthesis around that radical 2 or then enter, and then divide it by 3. And you should get 379.1. Alright, now last little question here. If I asked you to explain the similarities and differences between surface area and volume, what would you say? What does surface area do? It covers the outside, right? All the exposed part. Okay, and what is it measured in? Square units, right? What does volume do? It fills it up on the inside, right? And it's measured in cubic units, right? Okay. All right, you guys should have your workbook pages.